Greetings, AP Chemistry students. Today, we're going to be talking about the last type of chemical reaction in Unit 4, which is acid-base reactions. And acid-base reactions are proton transfer reactions. And let me clarify that a little bit, because if you think about what hydrogen is, a hydrogen atom, it's a proton and an electron. Well, we're going to be dealing with the H plus ion, which is hydrogen that has lost its electron. So essentially, it's just a proton. So acid and base reactions, you're transferring protons or H pluses, as opposed to redox reactions where you're transferring electrons. So they're a little bit different there. So don't get them confused. Now, we're going to be focusing on what's called the Braunstead-Lowry model of acids and bases. There's really three different ways to define acids and bases. There's the Arrhenius model, which you probably learned about in honors chemistry. There's this model, which is more encompassing, and then there's the Lewis model that we're not going to cover in this class. But according to the Braunstead-Lowry model, acids are proton donors. In other words, acids provide or give up H pluses, and bases take them. And then you have what's called a conjugate acid that is produced after the base accepts the proton, and then a conjugate base is produced after the acid donates the proton. Because essentially, after something gives up a hydrogen ion, it could then accept one, or after it accepts one, it could then give it back up. Because these reactions are typically what we call reversible reactions, which will be a key part when we get into units 7 and 8, which is equilibrium and then acid-base equilibrium. So we're just covering the broad strokes of this now. We'll get into much more detail with it later. Now, water is an interesting case because water can be an acid and donate a proton, forming the OH minus ion, or water can be a base and accept a proton and form the H3O plus ion. So, as an example, we look at HCl plus H2O makes H3O plus and Cl minus. In this reaction, HCl is giving up a hydrogen, making it an acid. Water is accepting it, making water the base. If we look at what we have made, since water is the base, its conjugate acid is H3O plus, which has the fancy name hydronium. And since HCl is the acid, its conjugate base is Cl minus over here. Because remember, just kind of keep in mind a little way of remembering this. The hydrogen ion, the H plus, goes from acid to base. So it goes from the acid to the base. Acids give up hydrogens, bases take them. So HCl is giving up a hydrogen, water is gaining it. If the reaction ran backwards, essentially, the H3O plus would be giving up the hydrogen, acting as an acid, and the Cl minus would accept it, acting as a base. So that's how we would label that here. So HCl donates a proton, which H2O accepts. In the reverse reaction, hydronium donates a proton, which Cl minus accepts. Right? So if we take a look at these two examples here, we have this first one, HC2H3O2 plus H2O makes H3O plus and C2H3O2 minus. So essentially what's happening in this reaction is that this hydrogen is going from the HC2H3O2, which is called acetic acid, to the water. So that makes acetic acid is the acid, water is the base. And then over here, H3O plus is the conjugate acid, and acetate is the conjugate base. So if you were asked to list a conjugate acid-base pair, that would be the acetic acid and acetate, or the water and the hydronium. A conjugate acid-base pair differs by just one hydrogen ion. See, the difference is one H plus between the acetic acid and the acetate. We take a look at this second example down here. NH3 plus H2O makes NH4 plus hydroxide. So the NH3 is gaining the proton, so that makes it the base. Water is giving it up, making it the acid. OH minus would be the conjugate base, and NH4 plus would be the conjugate acid. So water and hydroxide are a conjugate base pair, and then our other conjugate acid base pair would be ammonia and the ammonium ion. So essentially, you're going to need to be able to identify in a reaction what's an acid, what's a base, what's a conjugate acid, what's a conjugate base, and then identify the pairs that go together, the ones that differ by just a single hydrogen ion. And you'll notice in these two examples that in the first example, water was a base. In the second example, water is an acid. There are quite a few substances that can do this. There's a real fun term for them. It's called amphoteric. You don't have to know that vocabulary word, but that means it's a substance that can act as both an acid and a base.